Hello, my dear warriors. Welcome aboard. Welcome aboard. Welcome aboard. Hello, Khushi. Hello, Ivan Joseph. Hello, Shubham. Hello, Sachit. Welcome, guys, to the JEE English channel. And today's session is basically, like you can see in the simulation as well. Yep, we're going to do fluids, guys. Hello, Viti. Welcome, guys. And yep, fluids, problem solving along with some amazing PYQs. So if you're wondering what kind of fluid topics are we going to solve today, so statics like pressure, hydrostatic pressure, buoyancy, flotation, then hydrodynamics where Bernoulli's principle, equation of continuity and all of that is there. Then we'll also go to viscosity related problems like terminal speed, Stokes law and all of that. And then we'll also do some surface tension like the capillary effect, bubbles and all those things problems. So all of this in today's lecture with me, Shreyas Sir, physics master teacher. I have been training and nurturing kids for more than 10 decades, and I'm very proud and happy about the fact that these kids are doing really well in their life. Many of them, thousands of them, are now NITians, IITians, BITCians, and so many students are doing extremely well wherever they are. So next year it's your turn, or maybe even before, after that. So stay tuned on the channel with me. You can also be my friend on Instagram. That's Captain_Shreyas. That's where you can find me. That's my handle. All right. I hope you have smashed the like button and also hit the subscribe button. Let me just get you guys up on the screen as well. Nice to see all of you guys. Hi Pratik, thank you for all the kisses, bacha. Thank you, Hari. I'm very good. Khushi, I'm very good, bacha. Nice to see you guys back. Mr. Unique Boy, good evening, Biti. Even Joseph, even if you have watched all my live classes as promised, you couldn't watch, okay? So I was finishing my backlogs, but I will make sure to see everything. That's a very good promise. Even Joseph, I really hope you finish everything as soon as possible. And target maybe January or max to max February 1st or 2nd week to complete the entire 11th syllabus, okay? So that should be your target. Hello Ramu, hello Kirtana, good evening Bachalo. Let me also remind all the warriors, first of all, smash the like button. What are you guys doing? Don't wait for me to tell you, go smash the like button, go hit the subscribe button. You should do it on your own. There is this amazing playlists which are there for all of you, freely available on our channel. So just have a look at it. I'll tell you, this is last minute revision like one shots and all of that, formula revision, problem solving, etc. Then you have 12th standard detailed playlist and also 11th standard playlist. So let's say, for example, if you open this physics playlist over here, you can see right from units and dimensions, SHM, rotation, waves, all the chapters, detailed classes are there. Make the best use of these classes just for you, okay? So that's why I tell you, subscribe, because or else you'll miss all the things which are going to go on, and the announcements which are going to go on. How many hours do I need to study for going to IIT? In 11th standard, at least keep it 4 to 6 hours. At least I would say 4 hours to 6 hours. When you go to 12th, then I'll tell you it has to increase to 5 to 7 hours. That's what I would say. Yes, you are my friend on Insta, but I never get a reply. Okay, so sorry, Kushi. Happens, but I'll try to reply, bacha. I'm very good, Ragul Kana. Hello, Mani. Hello, Alvin. Nice to see you. Hi, Mani. Welcome. Welcome, guys. Let's begin with the class and let's start. Oh, yep. Let's start. All right. I hope you guys are all ready with it. Okay, so let me also tell you, join the Telegram channel. That's where you're going to get the entire sessions PDF, okay? So it should be a part of it. Where do you find the Telegram channel? Go down in the description box. You'll find a beautiful link to join the Telegram channel. Let's start with the first question coming up on your screen, guys. Here it is. For each and every subject, no, together I am saying, Hari. Together, 4 to 6 hours in 11th. And then when you go to 12th, 5 to 7 hours. That's good enough. Okay? I hope this is clear. Let's see how to solve this. Okay, but Khushi, remember, you only gave a suggestion, sir, please conduct a session on fluids, and here I am conducting a session. Okay, maybe I did not reply, but I heard your inner feelings, every student's inner feelings, I know it. A vessel of some volume contains oil at some pressure. When you apply a further pressure of this much on it, then the volume decreases. What is the bulk modulus of that oil? Thank you so much, Ramu Pantla. So here it is. The bulk modulus formula is nothing but delta P, the pressure which changes upon the fractional change in the volume. So if you want to just put a modulus, that will be better. It's bulk modulus, so mod value. So fractional change in the volume. This is always delta P, which is very important. Now understand one thing over here. This is basically your initial pressure, and when a pressure of this much is applied, this becomes your excess pressure. This is your excess pressure, that means delta P. So when you substitute delta P, what you're going to substitute is not this, but it will be this. So it's going to be 1.2 into 10 to the power 5. Change in the volume. You can see the volume changes by 0.3 10 to the power minus 3. So 0.3 into 10 to the power minus 3, whole thing divided by original volume, which is just 10 to the power minus 3. Obviously 10 to the power minus 3, 10 to the power minus 3 cancels. You can easily shift this decimal on the numerator and the denominator side. So it will become 12 by 3 into 10 to the power 5. 12 by 3 is 4. So 4 into 10 to the power 5. That many pascals. That's the answer. Yep, answer C. Very good. Awesomeness. Now, a lot of you are wondering, what do I do with this? Nothing. It's just there to confuse you. Number one. Number two, sometimes the question could have been completely different. They could have asked you, what is the compressibility? If they asked you, what is the compressibility of this particular gas, what you're going to do, you're just going to take the reciprocal of bulk modulus. So it will be 1 by 4 into 10 to the power minus 5. So that's what the compressibility is. Yep, definitely, Alvin. If the chapter has not yet started, watch my nurture series. I have conducted, I think, 1 class or 2 classes on this chapter. You will be able to understand it straightforward. Okay. So Renuga, I have already made a video on when to expect the JEE Mains first exam. Just watch that video. I just made it in detailed manner. Why not to expect this, when to expect it, what should be the preparation. Everything has been explained by Renuga. Okay, please watch it. Okay, moving on to the next one. Here it is. There are 2 blocks, A and B. Iron and aluminium have same weight and immerse in water, and now they are weighed. If the densities are given, then who will weigh more in water, or the data, not the date, it should be data, guys. Okay, so the data, is it insufficient? What do you say about this? Okay, let's try to solve this question using the concept of apparent weight. Why apparent weight? When you are measuring something in some another fluid, there is a buoyant force acting on it, because of which the actual weight becomes less. So when you take any object, its actual weight might be W, but there will be a buoyant force on it. Hence, the apparent weight of that is the actual weight minus the buoyant force. So it is W minus V, rho and G. Now, it is clearly mentioned, in air, they may weigh the same. They have the same weight in air. So let me just write it in the terms of mass. So mg minus volume. Volume of the body is nothing but mass divided by density, right? So it will be the mass divided by the density of the solid into rho into G. Notice that this rho is of water. This is the density of water. This is of aluminium or of that iron block. That is the density of the solid. That was the density of the liquid always. Now that is your apparent weight. Now what I will apply is a simple relation of whether it will increase or decrease. It's clearly seen that the density of iron is more than density of aluminium. So if the density is more, then this whole term, because density is below, it will decrease. It will decrease. And because there is a minus sign in front of it, because you are subtracting a smaller value from mg, this number will go higher. Is that clear? So the one which has more density has higher apparent weight. So obviously from this, the density of iron is more than density of aluminium. This was 8,000, obviously is more than 2,700. So weight of that iron will be more than the weight of aluminium. So iron was A, I think, and aluminium was B. So A will weigh more than B. So A will obviously be more than B. Is that clear? Option A. Yep, Mani, I didn't reply for me. Homework in Tattva. Which one, Bacha? Have you messaged me somewhere or something else? I'll definitely try to reply. Is this question available in PDF? Yes, Kritina. Yes. This will be available as a PDF later on. Yeah, in a day I'll try to put it up, definitely. For now, so those students who are probably new or probably not used to my teaching style, let me tell you, right now in running notes, try to solve, okay? And try to follow whatever I am saying. See if you are understanding which concept to use. I don't want the final answer. Even if you don't give the final answer, it's fine sometimes. But try to understand the concept, see why I'm using it. That's more than enough. Later on, you can get the PDF and you can probably, put it in your notebook or just probably save it in a folder, whatever you are comfortable with, okay? And if you're watching it recorded, you can always pause the video and you can take some time to solve it. It's completely up to you, okay? Hello, Aishi. Yes, viscosity is over long time back, bacha, but I will be doing problems on viscosity today, okay? So quadratic with, I have done viscosity chapter in nurture series. It's there in the playlist. 3 vessels shown have the same base area. This area at the base is same. And it is mentioned equal volumes of liquid are poured in it. Oh, the force on the base will be more or less in which of the following? Beautiful question. Equal, says Renuga. I doubt it. That is not the correct answer. It has equal volume. That is very, very important. Equal volume, that means if I take some water, let's say 10 ml or 1 liter, if I pour 1 liter here, because the mouth is little bit wide open, it will spread like this, and probably this will be the level of that liquid. Here, because it's not so wide, it's vertical, maybe it will fill till here, right? It will probably fill till here. The height of the liquid will be slightly more than this. On the third case, in the third container, it's narrower, so obviously it will grow taller in this case, so it will be slightly tall. It will be more in height, you can see, something like this. Now observe, now clearly observe this. At this point, the force which will act on the base is the pressure on the base into the area of the base. It's clearly mentioned that all of them have the same base area. So A is same. Force is pressure into area. Pressure is obviously dependent on height. So it will be atmospheric pressure plus rho GH, this thing into area. So that is your force on the base, right? Now, if you go logically, you will see that this is less height, this is more height, this is the max height. So here H is more, here H is less. So the one which has more height will have more pressure, will obviously have more force. So hence, if the height is more, here the force on the base will be more, here the force will be less, here it will be medium. So C will be highest, hence option C will be the correct answer. Yep, option C. Very good Renuga, very good Akshaya, Jayant, Sai Varshit. If it was not mentioned equal volume, if it was mentioned equal height, then what will be the answer? If it was mentioned, it's not equal volume, this word was not there. Instead it was mentioned, it was poured so that the heights are equal. Then what will be the answer, guys? Long time, Ishan. Yes, nice to see you back. I hope your ALI classes are going great. Hi, Rudra. Thank you, Cyber. Thank you so much. Means a lot, bacha. Thank you so much. Name of the chapter in NCERT, it should be called Mechanical Properties of Fluids or Fluid Mechanics. Just check it out. Okay, so that's what it will be called. Fluid Mechanics and Mechanical Properties of Fluid. Yes, equal. Yes, then it will be D. Very good, Khushi. Very good, Kritana. Very good, Jayant. Excellent, Sai. Renuga. Very nice. Excellent. Excellent. If it was equal height. Let's move on to another question. Now, this is a PYQ. Like I promised you, there will be PYQs also in today's session. So, you will learn how to apply theory, concept.
I found this on the web. For what is equal height?
Man. Woman, please. Calm down. My Siri, no. Even if it's so weird. I don't know what setting to do now. I've turned on internet. I have turned off internet. It's on airplane mode. It's on do not disturb mode. I have turned off the volume. Still, she will have to blabber something. I don't know. She just doesn't listen. Okay. That's my phone craziness for you. A jar is filled with 2 non-mixing liquids. You can see this one is liquid 1, liquid 2, liquid 3, density rho 1, rho 2, rho 3. This body is trapped in between. It's neither sinking nor floating. It's trapped somewhere in between. So guys, the question is, which is the correct order of the densities? What is the correct order of densities? Obviously, think about it. Liquid 1 floats floats over liquid 2. Liquid 1 is top on liquid 2. So density of liquid 1 will be less than density of liquid 2. Is that clear? Okay. Next important thing. Solid 3, that ball which is having density 3 sinks in 1 but floats over 2. So if it sinks in 1, that means density of 3 is higher than density of 1, right? And it floats over 2, that means density of 3 is less than density of 2. So 3 is less than 2 but more than 1. So it's in between 1 and 2. So from both of this, from all of this, what relationship holds true? Yep, is it D? Density 1 is least, density 2 is most, then density 3 is in between of them. Exactly, option D, correcto. Oh, why have I put the other way round? I think the answer marked is wrong over here. My bad guys, it should have been exactly opposite. The person who made the slide who gave the wrong answer, don't worry. So I'll change it. This should be the correct answer guys. So when you get the PDF, you will be getting the correct answer. Don't worry about it, okay? Is that clear guys? Shall we move ahead? Okay, let's move on to another question. You got selected, Rahul. Very good, bacha. In interview, what questions they will ask? They will ask you general questions. Any questions they can ask you, but conceptual. Very, very simple conceptual questions to check whether you have come, whether from cheating or from basically through, knowledge. So that is just for that. So it's very easy to gauge, whether you have come from your inner knowledge and all of that. So it's just that. Don't worry, it will not be very complex questions. Very good. Congratulations, Rahul. I hope you passed the interview as well. I'm pretty sure you have done well. A solid uniform ball having volume V and density rho floats in the interface of two liquids. In fact, the second liquid is not seen here. So maybe I will just show it like this. Okay. The density of the upper and the lower liquids are rho 1 and rho 2. So this is rho 1 and this is basically rho 2. This is rho 2 and this one is basically rho. So the question is, what fraction of the volume of the ball is in the lower liquid? What fraction of the volume of the ball is in the lower liquid? Okay. Now this is very much similar to the previous question, but here it is numerical type. So understand, in this question you will have to go with the free body diagram, calculative part and everything. So here is what I'm going to do. Let's assume this is the sphere, okay, and let's say in the upper liquid V1 volume is immersed, which has density rho 1. In the lower liquid V2 volume is immersed and density is rho 2. The actual density of the solid is rho. Okay, that's what it is. Now what will happen? There will be buoyant force. Buoyant force always pushes it up. So there will be buoyant force 1. There will be also buoyant force 2. There will be also buoyant force 2. And there will be also the weight of the solid. This is the weight of the solid. In equilibrium, these two upward forces will be balanced by the weight, correct? So can I not say the weight will be equal to F1 plus F2? So what is the weight of the solid? The weight of the solid is mass into gravity. So it is nothing but mass into gravity. Now mass into gravity, mass I can write it as density into volume into G, right? So this is what it will become. So that's your LHS. Mass is density of the solid into the total volume. Next, what is F1? Buoyant force because of only that part which is immersed in that liquid number 1. That will be volume submerged in that, density of that liquid into G, right? So I'm just going to keep it there. Plus F2. F2 will be nothing but volume of the liquid submerged in that liquid, density of that liquid into G. Great. Now I can clearly see GG cancels from everywhere. So I don't even have to write this G over here. But if I read the question over here, then I can probably realize which of these variables are very crucial and important for me. Fraction of the volume of the ball in the lower liquid. In the lower liquid means I'm talking about V2. Fraction of the total volume. Fraction of the volume, that means the total volume is V. Out of that volume, how much volume is inside the lower liquid? So V1 is of no use to me. V1 is of no use to me, and we know that V1 plus V2 is equal to V. So V1 is V minus V2. V1 is V minus V2. So how about substituting that over here? So if I substitute this as V minus V2, V minus V2, everything else as it is. So this is rho 1 and rest of it is plus V2 rho 2. Now let's solve this and see what do we get. Okay, so if I expand this, this will become rho 1 V minus rho 1 V2 plus rho 2 V2. Great. So bring V terms on one side. So it will become V into rho minus rho 1 is equal to this. I can take V2 common. It will be rho 2 minus rho 1. So therefore V2 by V1, V2, sorry, not by V1, by total V, V2 by total V will be rho minus rho 1 upon rho 2 minus rho 1. Rho minus rho 1 upon rho 2 minus rho 1. I can multiply this with minus 1. So V2 by V, if I multiply by numerator and denominator with negative 1, it will be rho 1 minus rho. I'm just changing the order, and this will be rho 1 minus rho 2. I think this option is there. Where is it? It's option C. That's it. So I've just used equilibrium concept that the net force should be balanced. Buoyant force by this liquid and this much liquid will be the total weight, and you have substituted the formulas. Also the concept that the total volume V1 plus V2 will be capital V. That's it. Very good. Cyber, awesome. How many hours you need to study for JEE Mains? If I start my preparation from now, JB for 2023, at least 6 to 8 hours, bacha. At least. It's okay, Shoaib, it doesn't matter. If it has tagged you as external, just okay. I don't know why it tagged you as external. Just raise a complaint using vCare. You have the vCare facility, just write a complaint on vCare Vedantu, because if you are a vPro student, you have access to vCare also. Just write to vCare, it will be solved. Okay. Now, next question coming up on your screen. Beautiful question on flotation. It's a cone which is submerged in a liquid and it's floating such that 90% of it is inside water. Question is, what is the relative density of the solid with respect to the fluid outside? Interesting. So this is basically 90%. 90% of it is inside. Okay, so fine. What is the relative density? Now, when I draw the free body diagram, I just know one thing, that there will be obviously the weight of the solid, that is the weight of the solid which will be acting down, and there will be also buoyant force. Buoyant force will be only because of this much part of the fluid. Buoyant force will be only because of this much part of the solid which is immersed in the fluid. That's it. It's not because of the entire volume. These two forces will balance each other. That's when it will be in equilibrium. It will float. So clearly the buoyant force should be equal to the weight of the entire solid. Correct? Now in order to find the buoyant force, what will I do? I will say it is volume submerged into density of fluid into G is equal to weight of the solid. The total weight of the solid will be nothing but the mass of the solid into G. Now G and G will cancel. G and G will cancel. So I will get volume which is submerged into rho. Mass of the solid, can I write it as the density of the solid into the total volume of that particular cone? The total volume of that cone. Mass is density into the total volume of the cone, right? Okay. Now that I have come till here, this is the last step, after which I cannot do anything. I have to think now what else to do. Because after this, I do not know what is the volume of the submerged part and what is the total volume of the cone. So I think I'll have to use some logic. It is clearly mentioned 90% of the height is immersed. Lot of people, I know what they do. They assume that the volume is 90%. Renuga, even I thought that. So a lot of people, what they do, that the volume submerged upon the volume of the cone is 0.9. This is wrong. Clearly it is mentioned that the height is 90%. That's the catch. That's why it's a trick question. So what I will do, I'll use some geometry to solve the question. So if I draw the semicone, half of the cone, either this half or that half, it will look like this. Okay, this is the height of the cone, h. The radius, it's mentioned. The height of the block is the diameter of the block. Height of the block is the diameter, so radius will be h by 2. Is that making sense? Because height is equal to the diameter. Height is equal to the diameter, so radius will be h by 2. Everybody? Very good. Amazing. Moving on. Next, the part which is submerged. Let's talk about that. This much part. This much part. Okay. Now, this is 0.9 times of h as per the given question. This is 90% is immersed. So this one, R, is something which I do not know, which I can find using simple similarity. So using similarity of triangles, I can say R divided by 0.9h will be equal to h by 2 divided by h. This by this is this by this. This by this is this big by this big one, right? So you can again clearly see that h will get cancelled and I will be left with R is equal to 0.9 times of h, and this 1 by 2 comes over here. So this will become 9h by 20. That's your radius of this particular part. Why do I need that? Because I need to calculate volume. Observe how. Volume of the submerged part. What is the volume of a cone? 1/3 pi r square h. 1/3 pi into radius square into the height of the cone, right? So it will be 1/3 pi radius square. So radius is nothing but 9h by 20 square into height. Height is nothing but 9h by 20. Height is nothing but 9h by 20. 10, not 20, my bad. 9h by 10 is 0.9 times of height. Okay, into density is equal to, this is the density of the solid. The total volume of the cone will be again 1/3 pi r square, but in this case the radius is h by 2, so just substitute that. This is h by 2, right, into pi r square, okay, into h. H is nothing but this h. I hope this is making sense. Okay, so what and all gets cancelled? 3, 3, pi, pi, okay, h, this h and this h. So what am I left with? 9 square, 81, okay, into 9 upon 20 square, 400 into 10, okay. Then rho is also there. Here sigma is also there. Here only one number is remaining, I think 2 square. So that is nothing but 1 by 4, I suppose. Clear? Okay, now let's see what happens. Let's see what happens. This 4 goes with 400, 100 times. Correct? And now I can just shift all these terms. So density of solid upon this row downstairs will be 81 into 9 divided by 1000. That's it, guys. I'm just going to leave it over here. I don't think we can come to any conclusion at this particular point of time. All right. I mean, I don't think any of these options are matching, if I'm not wrong. Yeah, none of these options are going to match. So I think these options need to be changed, but this is the final answer. I'm just going to leave it over here. Yep, it's not going to match with any of the options. So the options are incorrect. So just ignore this. But that's it. That's the answer. Oh, Zoso, you solved 2021 paper and scored 207 marks. Is it good? Yes, it is very good, bacha. It's very good. It's good for practice. Yep. But you have to push it to 250 because 207 means 99 percentile. So if you want 99.9 and something like that, then you need to push yourself to at least 240, 250 and stuff like that. Yep. So this question had geometry involved in it, lots and lots of geometry, definitely, and it also involved the concept of buoyant force, which a lot of people make mistakes in, especially even while reading the question. They think it is 90% immersed inside the water. That is wrong. It is not 90% immersed. It is the height which is 90%. So that's something which you need to be very careful. This is not the correct answer. Ignore it. Okay. So the correct answer to this question is 81 into 9 by 100. Right. Let's move on to the next question. Yep. Here it is. There is a small hole at the bottom of a large vessel. If the water is filled up till a height h, velocity of the water is v. If the velocity of the water coming out of the hole will be how much if the height is 4h? Great. Let's see, how do we do this, guys? Come on. So we have a container. There is a hole and the liquid is filled in it like this. And there is a simple formula. If this is height h, the velocity of the liquid which comes out is root 2gh. This is your Torricelli's law, correct? Now, the new velocity v1 will be root of 2g. Height has been made 4 times of the original height. Root 4 is 2, so root of 2gh into 2. But root 2gh is v, so it will be 2 times of v. So the new velocity has become twice the original speed. Yes, Jayant, yes, Kanan, that's the answer. Option C is correct. That's it, straightforward. Excellent. Let's move to another question. Very similar, but this is a PYQ based question. A lot of times this has been asked as a concept in PYQs. A large tank has a hole of area A at the bottom. Now, water is also poured in a tank by a tube of equal cross section, ejecting water at a speed v. The water level will keep rising, no water will be stored, water level will rise and then stop, water level will oscillate. Okay, let's try to solve this. Yep. Sir, VPro students are taken into Ekalavya from regular tests. Yes, as well as the internal, that public test which happened. See, if in the internal test, if you have been performing like really good now, consistently, you will be taken automatically. Number 2, if you have given this test and you have done well, then also you will be taken. Yep. Okay, so let's try to solve this question now. First of all, okay, if I draw the diagram, so there is this tube of area of cross section A through which liquid is coming with a speed v. Now there is a container. Now there is a container in which the liquid falls, and there is a hole over here also of cross section A. Now from this also some liquid will come. Now what happens is, imagine if the height of the liquid is very small, then the speed will also be small through which with which the liquid comes out. If height is small, speed will also be small, but this liquid which is being poured into it will fall at a good rate, so the level of water will increase. If the height is small, then the level of water will increase. Now as it increases, understand, when the height increases, this speed will also increase. So if this speed increases, there comes a moment when there is some kind of equilibrium, then there is some kind of equilibrium where whatever water is falling in is exactly the water which is going out, and the height of this particular liquid inside this bucket is maintained. So at equilibrium, finally there will be an equilibrium. At equilibrium, the rate of water flowing in is the rate of water flowing out. Equation of continuity, A into V will be equal to this A into root of 2gh. AA cancels, so V will be root 2gh square. So V square is 2gh. So H is equal to V square by 2g. So this is the equilibrium height for which the water level will neither increase nor decrease. If it goes up, then the speed will increase, then the water will be ejected fast and it will come down. If the height is less, then the water will come out slowly, so more water will come in and it will rise. So it will always try to balance itself at that equilibrium. Is that okay? Everyone? Very good. Zoso 112, close enough, because there are very few seats from what I heard. Like we hardly take, I think, 100 or around that number only. I'm guessing you are on the borderline. Most likely you should be through. I'm not sure, but hopefully you should be through, because there is one more test which is going to happen. Students might improve their ranks. More students might give the test. So based on that, the entire result will be collected and then the final scores will come. Okay. I'm so glad, guys. So many of you can't understand Hindi and we have a channel for you. We were the first, I think, in the country to be consistent, to do all the things in pure English for all the aspirants of JEE NEET. And I'm so glad that it's been more than 2 years now that we are here on this channel. And thanks to your love and support, guys, we are growing. So spread the word. All the students who even know Hindi, I mean, if you are studying in English medium, I feel that you should be watching this channel, because I mean, eventually in life you will be talking, conversing in English with so many other, of your colleagues. And obviously when you go to colleges or maybe go abroad, you will have to learn in English. So I'm so glad you guys are making that effort and coming on this channel. Really, really great. Cyber entertaining, I'm very good, very, very happy. And obviously, as usual, very excited to conduct these classes. Okay, yep. So moving on to the next question on your screen, guys. Water rises in a tube to a length of 10. If the tube is inclined, then the water will rise to how much height? Can I enter the batch? If I score rank 2, definitely Rohan, you will be inside the batch, definitely. But you have to clear the interview also. So here is the logic. If you have a capillary tube and let's say the water rises till this much height, so that is 10 centimeters. So that is in this particular tube. Now the moment you make the tube inclined at 45 degrees, at basically 45 degrees, what happens is, whatever this height is there, the same height the liquid will go, same height. So the liquid will fill till here. So what is important is, when you calculate this length inside the tube, this length cos 45 is basically the height. This length cos 45 component is the height. So that is basically 10. Cos 45 is 1 by root 2. So L is basically 10 root 2 centimeters. That's the answer. Is it B? No, it is option A, bacha. It's not C also. Kanan, Berson, be careful. Jayant, it's not about not selected. We are still processing. The 2 tests have to happen. Only once both the tests are over, there is a test on 24th, then the final results will come. Okay, hold on. Have patience. Okay. Sir, for NEET best college Cheppandi, sir. Sai Varshit, for NIT, sorry. NIT best college Cheppandi. Warangal is very good. Sai, I mean, that's your home state. I'm believing you are from Andhra, right, or Telangana. Then obviously you have Trichy, then you also have Surathkal, and then you have basically Calicut, and then comes your Surat, Nagpur, Bhopal and all that. If you get into Warangal, Trichy or Surathkal, blindly go, you will get very good placements. Even if you have to go to US or abroad or study further studies, it has very good reputation and has very good connections also. All right? Yeah. So all the 3 campuses are very good, bacha. Let's move on to the next one. Surface tension. A lot of students are going to make mistake in this, I guess. Surface tension. A film is held of area 0.02. The surface energy is about. Surface energy. Telugulo apadulo start avadadi, sir. Jai Sri Ram. Definitely. Yes. So I'll definitely conduct at least EMSAT classes. Jai Sri Ram. I know a lot of Telugu students are waiting for some EMSAT classes, definitely. So guys, what do we know over here? This film which is held by a ring, what is the energy? Guys, there is a very simple formula and I have given you the trick for it. And remember USA, United States of America, and put equal to over here. Energy is surface tension into area. Surface tension is 5. Area is given 0.02. 0.02. If you do it, you will get the wrong answer. Kanan is saying option C. Berson is saying option D. One of you are correct. Jayant, looks like you remember the trick. Very good. This is the formula, that trick which I told you. Now the catch is that this is not the area. You need to be little bit careful, because if this is your film, there is one area on this side. This is one side. And there is also another side. Second side. So there is a film, but it has 2 surfaces. First surface, second surface. So actually, I have to multiply this with 2, because there are 2 surfaces or 2 sides of the same film. If you don't multiply by 2, you will definitely get a wrong answer. So guys, 2 2s are 4. So it will become 5 into 0.04. 5 into 0.0420, so it will become 0.2. So 0.2, where is it? It's option C, guys. Yep, 0.2 is 2 into 10 to the power minus 1. That's option C. A lot of students miss that into 2. That's why you guys are saying D. Okay, that is not correct. Be careful. Okay, understood? That's why you are attending these classes. You'll be like, sir, I knew the theory, but still I made the mistake. Why you made the mistake is because you forgot the catch, because you forgot how to solve these questions. If you're not in touch with problems, you're bound to make these mistakes, and JEE will exactly pounce on these things. Okay, so next question. Will I revise complete syllabus by first attempt or important lessons? So cricket desk, most of the important classes will be revised, and depending on whenever your classes are getting over, we'll definitely have revision series for you. So come on, my warriors, figure this out. What will be the correct answer for this? Option A says Berson. Let's have a look. First of all, as you can see, the area of cross section is reducing. So here the area is more, here the area is less. As the area of cross section reduces, by continuity equation, what do we know? The velocity should increase because area into speed is constant. Also, using Bernoulli's principle, what do we know? Pressure plus rho gh plus half rho v square is constant, correct? So if the speed increases, height is not changing, so definitely pressure should reduce. So when you go from here to here, the area is reducing, speed will increase, hence pressure will decrease. There is only one graph like that where the pressure is increasing with the distance, and that is option A, guys. It is not B. Here pressure is increasing, here pressure is constant, here pressure is decreasing and again increasing. So it should be option A. Yes, it is option A. Awesomeness. So shortcuts for final exam. Sai, shortcut ले दो Sai Varshit. Shortcuts ले दो. ठीक है? There is only hard work. If you are thinking that shortcuts are there, yes, there are tricks. There are some things which you can eliminate, and I have made videos on that. You can search on the channel shortcuts, tricks, tips, last minute elimination methods, all those kind of videos I have made. But after a point, you cannot use many things, because if it was only about shortcuts, then so many people without studying theory would crack it. It would be just an exam. So yeah, tricks are there. I have already made some videos. I Varshit, just search for it on the channel only. Beautiful videos. Okay, how to guess, how to mark options, strategy, all these things I have made. Okay, and formula also I have made. Yes, there is one 3-hour or 2.5-hour formula session on the channel. If you have not seen it, please see it. It's there right over here. So in the playlist only, right? If you go in the playlist tab, see this complete formula revision playlist. Click on this complete formula revision with the tricks, exactly what you asked. Okay, I have conducted this 2.5-hour class. Will you watch it? Watch it, you will get it. Jayant, I don't know much Telugu, but little bit cheppu. That's all. Okay, so let's do the next question on your screen. Here it is. Sir, I am NEET dropper. Will I be able to complete my preparation if I start now? Yes, Srigori, definitely. But start now, don't wait. Soap bubble is blown slowly at the end of a tube by a pump by supplying air. Which of the following graphs represents the correct change in the excess pressure in the bubble with time? Let's try to solve this. Okay. Now, here is the logic, guys. See, in a soap bubble, there is some air inside, and this air has some excess pressure given by 4s by the radius. Now, as per the question, what has happened is air is blown inside of it. The moment you blow, obviously the radius will increase because it is going to grow in size. Obviously, R is in the denominator, pressure excess will decrease. So what should happen as the time progresses? More air is coming, radius is increasing, pressure is reducing. So there is only one graph like that, but it will be inversely related because you can see delta P is inversely related. So it has to be a curved graph, inverse graph. So as radius increases, pressure decreases. That's option B. Very good, Barson, Kirkumar, awesome, Titli, Arvin, very good, Vampire 127, awesomeness. Moving on to the next question on your screen. There is a liquid, and what happens is it is at the same level in a YouTube. It's a PYQ kind of question, and there is area of the cross section on both the limbs are same. If you accelerate those limbs together with an acceleration A, then what is the height difference in the liquid? Now this problem, you know what I can do? I can think of, you know, this U-tubes not being there. I can think of just a container and just imagine in a container which is like this, when the moment you accelerate, it's going to fall back, the water. Okay, the water is going to fall back. It's definitely going to make certain angle theta. In fact, this theta will be such that it will be perpendicular to the net gravity or the effective gravity. What do I mean by effective gravity? See, there is this actual gravitational pull which is acting downwards. Correct? Actual gravitational pull. But when you accelerate it, there will be a pseudo force acting backwards. Pseudo force value is ma. Forget the mass. The acceleration part, if you consider, that is going to be a this way. This is because of the pseudo force backwards. Force is mass into acceleration, but considering only the acceleration component of it, that's going to be a in the backward direction. Is that right? And now what you can do, yeah, you can do it by dimensional analysis also. If this is theta, obviously if you apply geometry, you will see even this is going to be theta. See, if this is theta because this would be over here 90 minus theta, this is 90 and so on and so forth. So you can see this is theta, this will be also theta angle. Now from this, what you can say is that tan of theta for acceleration, tan theta opposite by adjacent, it will be a by g. Also tan theta, if you look at it for this triangle, this will be h, this will be L geometrically, height opposite by adjacent, equating both of them, obviously h will be, or h by L will be a by g, or h will be AL by g. That is the answer, AL by g. Now why did I take a big container and forget the limbs? Think, even if the limbs were there, it will be just here. It will be just over here, that's all. So the liquid will be there only in this part. It will be only there in this part. So whether the full container is there or part of the container is there, the shape or the surface of the fluid will be inclined only at this particular angle. So I just took a big container to make it look very easy. So that is the trick for solving this question. So LA by G, AL by G, one and the same thing. Option B, very good. Correcto. Moving on to the next one. PYQ question. Let's try to solve this. Out of these graphs, which is the correct graph of the journey of the ball which is dropped inside a liquid when you draw it for speed versus distance? As the ball drops, as it covers some distance, how will the speed change with distance? Very simple. So when you drop a ball, obviously when you drop it, what happens? The velocity is 0. Then the velocity increases more, and then it remains constant. The velocity becomes constant, and that is called as your terminal speed, right? That is called as your terminal speed. So it should increase and then remain constant. I think there is only one graph like that. Check this out. It's remaining constant. You can see that. This would be your terminal velocity. So it's option C. Yep, very good. Very good, Renuga, Kanan. Looks like everybody jumped onto this answer. Very good, Titya. Very good, Vampire, Rohit, Sai. Excellent. Everybody knew this. Next, JEE 2004 question. Two bubbles of different radii are connected by a tube. Where will the air flow? Will it flow from the bigger bubble to small, small to big, or air will flow till the sizes are interchanged, or there will be no flow of the air? Interesting question. So we have a small soap bubble connected to a big soap bubble by a tube. By a tube. Question is, where will the air go? Sir, this JEE main will be tough. Berson, I think it may be tough. I think it could be. Because last 2 years they were lenient because of COVID. This year I think they will get back. They're in full mood. So I think you should be prepared for the worst. It can't be tougher than 2016, 17 and all that, because that's it. I mean, last 2-3 years it was very simple. But again, you don't know, because there are so many sets, how they plan it. See, if there are many sets, then the paper level will decrease. If there are few sets, few attempts and only few days on which the exam is conducted, then the paper level will go up. Just keep this in mind. That's how it works. Okay, so I'll tell you what, the formula that one needs to use is delta P is 4S by R. The one which has more radius has less pressure. One which has more radius has less pressure. So actually speaking, this is at low pressure and this is actually at high pressure. And where does air flow? Where does air flow, guys? From low pressure to high pressure or high pressure to low pressure? Obviously from high to low, right? So this is how the air will flow, from high to low. So it goes from smaller to bigger. So this is the tragedy of life. Rich becomes richer, poor becomes poorer. So small becomes smaller, big becomes bigger. So that's what it is. That's what it is. No, it is not 2T by R psi. 2T by R is for a bubble inside of water. Bubble in air is 4S by R. Bubble in water or liquid is 2S by R. So that's why I've used that. Yeah, from the smaller to the bigger bubble. Excellent. That's right. Yes, vampire. Moving on to the next question on your screen. Here it is. Definitely, Langley Haukip. I'm so sorry I'm not able to pronounce your name, but definitely this will be very, very helpful for all of you. In the last question, why ball accelerates and then goes constant, Nagupalli or Uma Mahesh, the reason for that is, meanwhile others start solving. See, when initially it is left, there is very little viscous force, because viscous force depends on the speed, rho, it is 6 pi eta RV and all of that. As the speed increases, the viscous force also increases. And there comes a time where the weight is being balanced by buoyant and viscous force. So the net force becomes 0, hence the acceleration becomes 0 and it stops accelerating. And that's when the velocity becomes constant. Alright. Hello, Bhat Farhan. Alright, let's see if you can solve this question. Completely based on capillary rise. So whenever you put a capillary inside a liquid, the height till which the liquid rises is given by 2s cos theta by rho g r. Now, as mentioned in the question, if the tube of half the diameter, if the diameter is half, that also means the radius is halved as well. If you make the diameter of a circle half, radius is also halved. So this has become halved. 2 goes on the top, that means the height has been doubled. So RHS doubles, because in the denominator you are halving it, you are making it half, so 2 goes on the top. So the LHS also becomes 2 times. So earlier the height was 4, so 4 into 2 is 8 centimeter. So that's option C. That's option C. Yep, that's correct. Excellent, guys. Harnath, I can't hear you, sir. It's not possible, Harnath, because I can see my voice. Arrow marks are there. Those indicators are moving up and down, and others are also able to hear. Just check your your headphones, earphones, or speaker, or maybe just switch, restart or something. Is enough for formula, Shri Gauri? It's not enough, obviously, because you will have to go through the concepts, and sometimes some intricate formulas will be there. This though will cover 99%, 98% of the formulas, that formula session. But obviously there will be some or the other, some intricate, detailed concept somewhere will be there. So obviously it's humanly impossible to cover each and everything over there. So that's why you should watch some other things like detailed classes also. Yeah, but 98, 99% is covered over there. Okay, chalo, let's move on to the next thing, and that is basically a vessel. Okay, and there are multiple holes, and the vessel has liquid till 90 centimeters height. The holes are made at 20, 30, 45 and 50, where do you think maximum range will occur? Come on. Berson, why don't you leave a comment? I will reply to your comment. That will be better. Nagabali Uma Mahesh, you should solve 2000 to 2000 at least 20. These papers are good, 2018. These papers are good, and what happens is from 2000 to almost 2016, 17, 18, we used to have only one single attempt of JEE Mains. The questions are also good, so you will learn a lot. In this new generation, 2018-19 onwards, what has happened? Multiple attempts have been there, 2, 4 and all that. And each attempt had so many shifts. That concept was not there before. So that's why in the last few years, the pattern of the paper, the variety of questions is very limited. Even though the number of questions are huge, the pattern of the variety models of the questions are very limited. So you will not learn as such. So if you want to learn, then 2000 to 2016, 17, 18, that's where you will learn a lot. From 19 onwards, you can give it as a mock test. Like the entire paper, you can lift it and you can give it as a mock test. Okay, many of you are saying D and B. Let's have a look. Obviously, maximum range happens when the height is at height of the liquid level by 2. So that is 90 by 2, which is 45 centimeters. 45 centimeters is right over here, which is hole number 3. So hole number 3 will give maximum range. So that's option B, obviously correcto. Exactly, it's B. It's not 1, guys. Exactly at half the height, your range is maximum. Just like 45 degrees, half of 90, you get maximum range. Here, half of total height, you get maximum range. It will fall the farthest. Every other hole that you see will probably, it will fall here, or this might even fall here and something like that. All right. Let's move on to the next question up on your screen, and here it is. There is a ball of volume V. Okay, this is JEE 2008. You can see it's quite conceptual. If it is falling through a liquid, find the terminal speed of the ball. Viscous force is not your standard Stokes law. It is minus kV square. That's the catch. Let's try to do this question. First, let me draw the ball. So this is the ball. It is going to fall down with constant velocity. This is your terminal speed. Terminal speed. That means it is constant. And if it is constant, if speed is not changing, obviously acceleration is going to be 0. There is going to be no acceleration at all, right? So that is what I can conclude. Now, what are the different forces acting on it? Obviously, there will be one weight of the ball itself. This is the weight of the ball. Next will be a small buoyant force will be there on it. And obviously, this viscous force is also going to be there. Viscous force will oppose the speed. It is going down. Viscous force will oppose the motion this way. So, when acceleration is 0, net force should be 0. So, the weight of the ball should be the buoyant force plus the viscous force. Correct? Okay, what is the weight of the ball? What is the weight of the ball? mg. Okay, so I'm going to put mg over here. What is the buoyant force? It is the volume submerged. Okay, this is volume submerged into density of the fluid. Now, density of the fluid, what is the density of the fluid? Liquid of density ρ2. So, ρ2. So, I'm just going to put ρ2. Do you see that? Density of the liquid is given to be ρ2 into g. What is the viscous force? kV square. Now, you might be questioning, sir, why did you not put minus? Is this correct or wrong? This is correct only, nothing is wrong. Then you'll be like, sir, what about the minus sign? That minus sign is just to tell you that the force is opposing the velocity. That's all. So if you put minus kV square, you will definitely get a wrong answer. That's what they played with. They played with your mind. Many students put minus sign here. That is not at all correct. Is that understood? Clear? Let's solve this now. What is the mass of the ball? Mass is density of the ball. Density of the ball material is ρ1. So density into volume into g is equal to volume into ρ2 into g plus k into speed square. So k into speed square will be volume into G, volume into G, I can take it outside, and I will have rho 1 minus rho 2. Volume I can take it as capital V, G I can take it as G. This will become rho 1 minus rho 2. K will come downstairs, and this will become speed square. So speed will be root of this. So I think this should be the answer. This should be the answer. Just check this out. Option A. Yes, it is. So a lot of people make a mistake here. Number one. Number two, many people do not consider buoyant force. That's second mistake. Third mistake, they mess up with the directions of these forces and forget that the acceleration is zero. So unless you are aware of the derivation, you will make a mistake. So that's why I say derivations are important. Sometimes they can change some of the parameters of the laws, and then they will be like, okay, now find this value. So if you know the derivation, you can get it. Else you will be stuck. Next question on your screen. A 20 centimeter tube is dipped in water. Water rises till 8. If the entire arrangement is put in a free falling lift, what do you think will be the height of the water in that capillary? 2005, JEE 2005 question. So you have a lift which is performing free falling motion, and in that you have kept a capillary tube inside a container, and you are expecting how much liquid will rise in this capillary. Well, if you know the height formula, it is 2s cos theta by rho g r. Here g will be only 0. No gravity. You will not feel only any gravity. So what will happen to the height? This will become as large as possible. As large as possible. So if denominator is 0, LHS will become as maximum as possible. Here the maximum height that it can go is the length of the tube, which in this case is just 20 centimeters. So it will completely fill it up. Completely it will come till the top. That's it. It can't go above that. There is nothing above it. So maximum is 20. So hence option D is correct. That's why I keep telling. Somebody asks, sir, which PYQ should we solve? 2000 to 2016, 17, 18. That's a good era to solve the PYQs. Wow, that was the end of the last problem. Great. So guys, there are many announcements that I would love to make for all of you guys. Hear it out carefully. First of all, let me tell you, this year alone, from Vedantu, we had 2,688 students clearing JEE Advanced, more than 10,000 students clearing from mains to advanced. So there are thousands of students just from Vedantu sitting at home, learning online from the best of the teachers who went into the best of the colleges. That's the beauty. So all those of you who want to improve your ranks, who want to, get into the best of the colleges and want to study from the best, and not just that, guys, you feel that you're not getting the best or you are not getting the sufficient resources, make use of all the things that we are giving you. First thing is Ekalavya. Ekalavya is a free batch. You have really amazing teachers, really good material, very good test series, mock tests, doubt solving, everything, problem solving sessions, revision sessions, goes on till the end, till counseling. There is a free batch. And the test, one of them got over on 20th. There is one more test on 24th. If you have missed the first one, give the second one. These are the timings, 30 questions from each subject. If you feel that, no, sir, I'm not able to crack it, no issues. We also have the JEE crash course, which is going on. Through the crash course also, you can enter into Ekalavya if you perform well. So the crash course link is also there in the description box. Make the best use of it. Okay, so I hope you guys enjoyed. Thank you so much, Kushi, Titiya, Sarvajit. Very good. If you are preparing for NSCP, definitely watch these classes. Based on your portions, it will help you with the advanced concepts. KCT, yes, I will be conducting classes afterwards. Thank you. Glad, Harini, you enjoyed this. Bye-bye, Kushi. Take care. Have a great time. All the students out here who enjoyed this class and who learnt a lot from this. Share it with your friends. See you again in the next session. Tomorrow there will be a special session again at 7 o'clock. See you again. Bye-bye. Subscribe, like. Do not forget to leave a lovely comment after the video ends. This was Captain Shreyas signing off. Hasta la vista.